Okay, so now we get into the quantum numbers section of chapter 7. You may remember from intro chem class that when we're talking about an electron, we talk about what shell the electron is in, what subshell, what orbital, and if it is pointing up or pointing down within that orbital. You remember the spin. So we do electron configurations, we do orbital diagrams, and we're going to get into all of that in chapter 8. But in chapter 7, we give each electron in an atom 4 numbers, and they are called 4 quantum numbers. And each one of those quantum numbers represents something. Okay? What are those 4 quantum numbers? And by the way, each electron in an atom can have 3 quantum numbers exactly the same, but the 4th will always be different. So basically, you don't have any 2 electrons with the exact same 4 quantum numbers. They could have 1 the same, 2 the same, 3 the same, but never, ever, ever 4 the same. Okay? And you'll understand what I'm talking about as we go through this. All right, what are the 4 quantum numbers? Here they are. Let's see, right over here. Okay. N is called the principal quantum number. That stands for the shell number. So you know that you can have the first shell, second shell, third shell, all the way up to an infinite number of shells. So N, the possible values for N can be 1 or 2 or 3 or 4, all the way up to whatever, infinity. Okay? That's N. And you know that if N is 1, it is the closest to the nucleus, and the big N, it is the energy-wise, it's got the least energy. So as you go further and further away from the nucleus, as your N value increases, the electron in those farther away shells have more energy, and they're further away from the nucleus. Okay, so that's stuff that we can relate back to intro chemistry class, but now we're just saying that the principal, we're going to call that shell number the principal quantum number, and we'll give it a number anywhere from 1 to infinity. So if the electron is in the first shell, the first quantum number would be 1. If the electron is in the second shell, the principal quantum number, which is N, would be 2. Okay? The next one is L, which is the angular momentum quantum number, and that is the subshell. You remember the subshells were S, P, D, F, you could go G, H, etc., however many. So L, these are the possible values. We're giving these numerical values. We're not using S, P, D, F anymore. L could be 0, 1, 2, 3, all the way to N minus 1. So if your N value is 7, the L value could be 0, 1, 2, 3, and all the way up to 6. Okay? What do these mean? If L is 0, that relates to the S subshell. If L is 1, that relates to the P subshell. If L is 2, that is the D subshell. And if L is 3, that is the F subshell. And if L is 4, that would be G, and we can keep on going. Okay? I'm just going to focus on these guys because those are the ones you usually were introduced to in an intro chem class, S, P, D, F. All right, let's keep going. ML, that's the magnetic quantum number, and that tells you which orbital it's in. Remember how we said back in intro chem days that every subshell has orbitals, and we said that each orbital can hold a maximum of 2 electrons. So if, for example, we're in the S subshell, there's just 1 orbital. If we're in the P subshell, because it holds a maximum of 6 electrons, you're going to have 3 orbitals, each one with 2 electrons. And if you're in the D, remember D can hold a maximum of 10 electrons, so you're going to have 5 orbitals. And if you're in the F, you can have 7 orbitals because you can hold a maximum of 14 electrons. Again, that ties into all that intro chem stuff that hopefully you still remember. So, what are the possible values for ml? The way to figure that out is that you can go from minus L all the way through 0 to plus L. Well, what does that even mean? Well, let's say we know that L is 2, for example. So what are the possible ml values? So I'm going to write here, if L is equal to 2, then the possible ml values would be minus 2, minus 1, 0, plus 1, and plus 2. Okay, that's how you can relate all of this. Now, if you remember what I just said here, if L is 2, that's the D subshell. And if you remember from intro chem days, D holds a maximum of 10 electrons. And that means it would hold a maximum of 5 orbitals. It would have to have 5 orbitals. And here we go, 5 ml options. So this would be like the first orbital, the second orbital, the third orbital, the fourth orbital, the fifth orbital in the D subshell. Okay, and then finally, what is MS? MS is the spin quantum number. What do I mean by spin? Remember how when we did orbital diagrams in intro chem days, we would do arrow going up, arrow going down in the orbital? Like we'd have arrow up, arrow up, arrow up, arrow up, arrow up, and then we would start to double up, and then it would be down. So basically, in each orbital, you would have 2 electrons, but 1 electron has to go up and 1 electron is down. They spin in opposite directions. So the MS value could be plus 1/2 or minus 1/2. So think of it as plus 1/2 being spinning up and minus 1/2 spinning down. You can think of it that way, all right? Or vice versa. But basically, you can't have them both being plus 1/2. So in each orbital, you're not going to have plus 1/2, plus 1/2. One's going to be plus 1/2 and one's going to be minus 1/2. Okay? So these are the ground rules. Now what we're going to do is we're going to start looking at 4 quantum numbers and trying to see if they make sense or if they don't make sense. Okay? Are they feasible or are they not? Are they permissible or are they not permissible? All right. Let's see here. Let me look at some. Hold on one second, guys. All right. So here's a set. N is equal to 4. L is equal to 4. ML is equal to 0. And MS is equal to plus 1/2. And the question is, are these permissible? Is this an okay set of 4 quantum numbers? Well, 4 means that it is in shell number 4. This one's fine. L is 4. Remember how I said the rule is that L can be 0 all the way up to n minus 1. So the maximum value for L when you have an n of 4 is 3. So this one won't work. So these 4, this is not permissible because L is wrong. Okay, let's try another one. Here's another one. 3, 2, 3, 2, 1, and minus 1/2. those are the four quantum numbers. Remember, the first one is N. This is L, principal quantum number, N, L, ML, and MS. Let's see if these four are permissible. Well, this would be the third shell. That's fine. This would be the subshell that, it can go from 0 all the way to N minus 1. So that works. This ML, remember how we said it can go from minus L all the way to plus L. So this means that it could be minus 2, minus 1, 0, plus 1, plus 2. So 1 is okay. And this could either be minus 1/2 or plus 1/2. This is fine. This is permissible. So all were good. Okay, let's try another one. All right, 2, 0, 0, 3/2. Okay, this is kind of obvious. It's a really easy one. All right, well, 2 makes sense. Yes, you could be in the second shell. 0, remember L could be 0 all the way to N minus 1. So 0 just means it's in the S subshell, no problem. This 0, totally fine because it goes from minus L all the way to plus L and this through 0. And so that makes sense. Yep, this would work too. If it's an S subshell, you only have one orbital, which has to be the 0 one anyway. Obviously, the error is right here. You can't have this. This is not an option 3/2, so this is not permissible. Okay, let's try another one. Okay. 5, 3, minus 3, and plus 1/2. Okay, principal quantum number, 5. Yep, we can be, that's, anywhere from 1 to infinity is fine. The angular momentum quantum number can go from 0 all the way to N minus 1, which is fine because this is N minus 2, which is totally fine. Well, this is good. This one has to be from minus L all the way to plus L. So it could be minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. So this is fine. Plus 1/2 is also fine because it could either be plus 1/2 or minus 1/2. So yep, this one's fine. This is permissible. Okay, and then one more. Just want to add this in here. All right, let's see if this one's okay. So 4 as the N value, totally fine. Okay, that's the that's the fourth shell. 3 is, so long as it's up to N minus 1, we're good. It could be 0, 1, 2, and up to 3, so that's fine. Here is where the problem is. Take a look. Remember, ML, the magnetic quantum number, can only be from minus L to plus L. So it can be from minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. This 4 would be illegal. So nope, this is not permissible. Okay? Good. So the purpose of this video was to introduce quantum numbers and show you that every electron is going to have 4 quantum numbers, but they have to make sense. And I'll probably do one more video for this chapter, doing a bit more of the quantum number practice, and then you will be all set with chapter 7. Okay.